functions to help you code more efficiently. In this video, we will discuss the function POW. Hi Python enthusiasts. Today we're talking about the POW function, a versatile, built-in tool for performing exponentiation and modular arithmetic. By the end of this video, you'll understand how POW works, when to use it, and why it's more than just a simple exponentiation operator. Let's dive in. What is POW? It's a Python built-in function that performs exponentiation and can optionally calculate a modulus. Here's the syntax. The argument base is the number that you want to raise to a power. The argument exp is the exponent to which the base is raised. Optionally, you can include the mod argument, if provided the function returns the base raised to the exponent modulo the mod value. The function returns a number, either the result of base exponent or the modular result if mod is specified. Why use POW? It's perfect for exponentiation and efficient modular arithmetic. The key concepts include: 1. It's equivalent to base exp for two arguments, but is clearer in intent. For three arguments, it computes base raised to the exp modulo mod efficiently, which is useful in cryptography and modular arithmetic. And it handles large numbers with ease, maintaining precision. You'd use POW when you're performing exponentiation in mathematical or scientific computations, when you're working with modular arithmetic in fields like cryptography, and when you need precise or efficient calculations for large powers or mod operations. Let's start with a basic example of exponentiation using POW. Here POW 2, 3 raises 2 to the third power, which results in 8. Now, let's add a modulus to the calculation. In this example, POW 2, 3, 5 computes 2 to the third power modulo 5, which is equal to 3. The modular calculation is efficient even for large numbers. The POW function provides clarity and efficiency over the operator, especially for modular arithmetic. Note that both give the same result for simple exponentiation, but the POW function is more readable when performing modular arithmetic. Let's look at an example involving large numbers. The POW function handles them efficiently, especially with a modulus. This is efficient compared to calculating with the large base raised to the large power directly, which would be computationally expensive. The POW function is widely used in cryptography for modular exponentiation. Here's a simplified example. In this example, POW computes 5 raised to 117 modulo 19, a fundamental operation in cryptographic algorithms like RSA. Here are some important points about POW function. With two arguments, it's equivalent to the operator. With three arguments, it performs modular arithmetic efficiently. And it's the go-to function for precision and performance in large number computations. And that's the POW function. To recap, it calculates exponentiation and efficient modular arithmetic. It's ideal for mathematical computations, especially with large numbers. It's a key function in fields like cryptography and number theory. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more Python tips. Happy coding!